In this video, I want to go and review some of the concepts associated with traversing an array. So let's say that we have an array here, and maybe this array has 5 elements. So 1, 2, 3, 4, and 5. And we know that the index values start at 0, so the first element has an index value of 0. Then we go 1, 2, 3, and 4. So the last valid index always is 1 less than the size of the array. The size of the array is 5 in this case. So if we were interested in being able to visit or traverse over this array, so being able to visit each individual element of that array, we saw how we could use a for loop structure. So let me go ahead and put some values in here. So maybe we have 2.1, 1.3, 0.5, 1.7, and we'll say 3.2. And maybe these represent rainfall values on particular days of the week, or at least the weekdays of a week. And going back to this for loop here, we saw that in this print array function that we could use this for loop to get to each individual element. So the for loop header, all that's doing is just getting us through each individual index. So you can see that I is going to be representative of our index. It starts at 0, and then our loop continuation condition, so basically this is the condition where whether we can get inside this for loop or not, test to see if I is less than size. So the last time that we can get in is whenever we're 1 less than the size. So that would be whenever we would have 4, since this is a 5-element array. So that for loop header is just simply going through every single index value. And it's the same concept down here for this user input array, even though we're doing something completely different in the body of that for loop. So here we were wanting to just print out the contents, whereas here we were wanting to get a value from the user and then store that value into an element of the array. So really the big idea that I'm trying to get across is that regardless of what we're trying to do, whether it's printing out the contents of the array, storing some new values into an array, we could traverse over and sum up the values to get the total of everything. We could get an average, so after we get a sum of this, then we could divide by the number of elements we have and get an average. So it doesn't matter what it is. As long as we're wanting to be able to visit each individual element of our array, we need to be thinking about this for loop structure. So it's going to be the exact same for loop header, and the body is the only thing that's going to be changing, assuming that we want to just be able to visit each element of the array and do something to it. So with that in mind, let's go over to Eclipse and maybe code up a new program where we calculate the average, say, of all the values in an array. Okay, so I'm over in Eclipse now, and I've already created a project and also created a file called average CPP. And I've done some of the normal things that we do. So I've done the pound include IO stream, the using namespace standard, and I've also created the skeleton of a main function. So what we're going to do now is just simply create an array, and then once we create that array with certain values, we'll average up all the values that are in each element of that array. So something new that we'll do is actually do the creation and initialization of the array all in one step. So we'll say that this array is going to hold maybe the points that a particular basketball player scored for a 5-game period. So this is going to be a 5-element int array since we don't have any fractional parts with points scored. So we'll say int, and then we'll say points is the name of this particular array. And since it's an array, we'll use open square bracket, close square bracket. Now we don't have to put anything inside of open square bracket, close square bracket here because we're going to be doing the initialization of all the elements at the same time of creation. So the way you go about writing the syntax for that is doing exactly what I have here. Of course, if it had a different data type, you would specify a different data type here, and then you specify the name, open square bracket, close square bracket, assignment statement, and then you would do the brace. So some people say the curly braces. And then we can specify however many points this particular basketball player scored over a 5-game period. So we'll say maybe 18 points, 20, 5, 17, and maybe 22 points. It's a fairly high scoring player there. The other thing I should mention is you could actually go in here and put in 5, and that would be perfectly fine, but it's not required. So the compiler, whenever we compile this code, is able to see that, okay, they're doing the syntax for creation and initialization all in one step, and it knows that we have specified 5 values here, so it's going to create 5 elements associated with this points array. So it's really up to you whether you want to actually place that value of 5 there inside the open square bracket, close square bracket. So we've created an array and we've populated it with some values. And now what we're going to do is write a function. So let me go up above. So I'm going to allow this particular function definition to serve as not only the definition but also the declaration, so we don't have to write a function prototype. So this is going to be a function that just simply calculates the average, and we know if we're averaging up some points here, we could end up with potentially a fractional part. So we'll say that this particular function returns a double value, and we'll just call it average. And what we're going to pass into it is just simply an array. So this should look familiar to you if you watched some of my previous videos dealing with arrays. So we got int array, open square bracket, close square bracket. So passing in the array and also passing in the size of the array. So those two pieces of information is needed. And then inside the body of this, what we're going to do is just, since we need to keep track of the sum of the points, we're going to create a variable called sum, and we'll say that this variable is of type double. So we'll say double sum assignment statement, and we'll just initialize it to 0.0. So before we actually traverse over our array, we'll say that, well, the average or the sum is going to be 0. The average would be 0 as well, since we don't have any values yet. So then we'll use our famous for loop header that we saw before. So we'll say for int I assignment statement 0, and we'll say as long as I is less than size, and then I plus plus. So exactly the same stuff that we saw before for being able to print out our array or being able to get values from the user and have them stored in the array. So it's the same exact for loop header, except this time we want to be able to have a running total. So we want to be able to add on to our sum each time through this for loop. So each iteration through, we'll just add in a new value with the next element. So the way we go about doing that is we will just say sum assignment statement, and then taking the current sum, which the first time through would be 0, and just adding that to the value stored in a particular array element. And the way we go about doing that is specifying the name of the array, open square bracket, I, close square bracket, and then semicolon. If you wanted to, you could use the shortcut operator here and just do plus equals as opposed to doing sum, assignment statement sum, plus array, and then the index value. So it's really up to you. So now that we have this, we can go ahead and we really don't need to do anything else except return this value. So we're going to just simply return the average, and the average would just be the sum divided by what? The size. So the size of our array. And that will give us the average that a particular player scored over a 5-game period. Now you may be curious as to why I use double instead of an int value for the sum, since all of our values would have ints. Well, the reason is if I would have had an int here for sum and size would have been an int, we'd have done what's called integer division. And certainly we could have cast either one of those, either sum or size, to being a double before we did the division, so that we don't just simply do integer division. But I figured it may be okay to just do this as a double here, and that way whenever we got down to doing this return statement and calculating the average, that it was already a double. So this is a double, this is an int, and it avoids doing integer division. So with integer division, remember that we just chop off, lop off, truncate any fractional parts we have, and we would like to have those fractional parts because they're meaningful. So we have that, and now we can go back into the main function here and just print out the results. So we can do cout, assignment statement, and just call our function. So our function is called average. So we'll type in average and then pass in points, and we'll also pass in the size here, which was a 5-element array, and then we'll do an indel here. So we've got that, and we'll go ahead and save it and build it. See if everything builds okay. Looks like everything built okay. And then we'll run it. So we can see here that the average for this particular player over 5 games, where he scored 18, 20, 5, 17, and 22 points, is 16.4. So this, video is not really about calculating the average or anything like that. It's really about understanding the idea that if we're interested in being able to visit each individual element of our array and do something, so whether it's sum up, print out, manipulate those values in some way, then we would want to be using this for loop structure. So that's it for this video.